atomic mass on the periodic table is the mass of a mole. All those masses give us the mass of 6.02 times 10 to the 23rd atoms of each of those elements. So even though they have the same amount of atoms, they might have different masses because they have different densities. And I want you to round these to 2 decimal places. Who's got a mole of carbon for me to 2 decimal places? 12.01 grams, because it's a mass. What about hydrogen to 2 decimal places? 1.01 grams. How about silver?
107.87.
So a bunch of you guys found that, 107.87 grams. So again, different masses for the same number of particles, 107.87. Okay? Now, if we want to do a compound, that's what I have next. We're going to add up the masses.
What was the last one?
And I'll help you with that. 107.87. Do you have to write that at the top? You don't have to. Yes. So, we already kind of went over this when we looked at the test tubes. We're going to take the elements, add them up, and that will give us the formula mass if it's an ionic compound, or the molecular mass if it's a covalent compound. So what I want you to do is look up each element separately, and then we can add them together. Who can tell me what the mass of the sodium, mole sodium is?
22.99.
22, you guys are looking up nitrogen. 22.99. What about chlorine?
35.44.
And the chlorine is 35.45. And these are all technically grams per mole. So it's not the mass of one atom, it was the mass of lots and lots of atoms. So to get the molar mass of NaCl, I'm just going to add them together. 22.99, 35.45, and that gives me 58.44 grams per mole. Easy. Okay. Now water has that 2 by the H. So you have to make sure that you include 2 H's and 1 O. And make sure you only put the subscript for the element that it's next to. Okay? Who can look up H for me?
1.01.
1.01. Remember, we're doing them all to 2 decimal places. And what's the O?
15.
Round it.
16.
16. So actually oxygen is 16.0. You guys are going to know hydrogen, oxygen, carbon, and probably nitrogen by the time we're done here. So when I add these together, I'm going to do 2 times the hydrogen plus the oxygen. 2 times the hydrogen plus the oxygen to get 18.02 grams per mole.
Grams per mole.
That's the unit, is grams per mole. So if you have 1 mole, it would be 18.02 grams. If I had 2 moles, it would be 36.04. All right, the last one I included a polyatomic ion in some parentheses so you can kind of see how that works. We don't have like masses for polyatomic ions on the back. You have to treat them as all separate elements. And when you have the number outside the parentheses, that distributes through just like math. So we have 1 magnesium. The 2 doesn't apply to the magnesium. The magnesium's not in the parentheses. How many nitrogens do we have? 2. And then you multiply. How many oxygens? 6. So let's do each element separately first. What's the mass of a mole of magnesium? Periodic table. Alkaline earth metal.
34.21.
How about 24.31? What about nitrogen?
14.01.
14.01. And then we already did oxygen. Oxygen was 16.
16.00 or 15.999.
Yeah, but it rounds up to 60.00. So when I add them together, I've got 1 magnesium, 2 nitrogen, so I'm multiplying it by 2, and 6 of the oxygens. Now, I do the other ones in my head. This one I cannot do in my head. Use my calculator.
I got 99.
All right, and I get 148.33.
Of course.
Now this can become our new conversion factor because that's the amount in 1 mole. What if I want 5 moles? Or what if I have 100 grams of water and I want to know how many moles that is?
multiply that by 100. You do.
Well,
1.
You do 100 over
we're gonna do this. We're gonna use it as a conversion factor. All right. We had atomic mass, formula mass, molecular mass. I like to call them all molar mass. Molar mass is the mass of a mole. So it doesn't matter like what kind of substance you have. If it says molar mass, it works for anything. And that's going to be our new conversion factor. So instead of putting 6.02 times 10 to the 23rd atoms or molecules, whatever, we're going to use the molar mass in that conversion factor. But we're going to take it through the same steps. So if I want to know the mass of 5.69 moles of potassium, what am I going to start with? What should I write down first? The number in the problem. 5.69 moles. And they're all going to be one step. And it says, what is the mass? Mass is measured in grams, so I'm looking for grams. Same setup. Get the units on the table. Julie, I had moles, so should I put moles on top or bottom? Bottom. So we can get that nice canceling action. Hannah, what unit should go on top?
Grams.
Grams, because that's our answer. We're still putting 1 next to mole. This entire unit, we're going to learn 3 different conversions. So we've done 2 today. 1 is always going to go by mole. What do I put next to grams? I'll put Avogadro's number. There's no scale that could weigh that.
39.
Where'd you get 39.10, Anthony?
periodic table.
Periodic table. That's potassium from the periodic table. So now in the spot, you have to look at the substance and put its mass in there. And then, of course, make sure you use significant figures. I have 3, I have 4, so my answer is going to have 3 significant figures, 222 grams. Now we're going to go backwards. This one's extra fun.
Is that a 222?
It's a 222. This time we're going to start with grams.
Is there significant figures?
There is, and we don't have to include the 1 mole, so we're just doing 3 here, 4 here. I went with the least. When we're adding, we just keep the 2 decimal places.
Yeah, no, but there's no decimal because you're not.
Because I'm not doing adding and
Now
subtracting.
it's setting up this.
So you only have to worry about decimals really if you're adding. Here, I want to know how many moles are in these grams. So let's do the unit thing first. Mason, what unit goes on the bottom?
Grams.
Michael, what goes on top?
Moles.
Moles, very good. Nika, what number goes by mole?
What is
1.
H2S?
1. Now, I think Anthony's kind of skipping ahead because he knows what's going on. This is kind of a problem in a problem because what has to go here by grams?
The H2SO.
The mass of the H2SO4. So I actually have to figure out
Oh.
2 times H
That's a big number.
plus 32.06, that's S from the periodic table, plus 4 times oxygen, which was 16.
Man.
And once I figure out the H2SO4, that's what goes in the conversion. So you actually have to add it and then put it next to grams. And now we can see that we're going to do 74.89 times 1 divided by 98.08. I need 4 significant figures this time. So I'm going to get 0.7636. And you know what? You don't have to do these in scientific notation because these are pretty normal numbers. With Avogadro's number, we really need scientific notation because that power of 10 is so large. So on your homework, on the front, you're just looking stuff up on the periodic table or adding it. On the back, you're doing these 2 types of conversions. Do you guys have any questions?
So for carbon, if you look